Hello, welcome to another homework for Paul McWhorter's Raspberry Pi Pico lessons. This one is number 20, and this week we are endeavouring to display temperatures from a DHT11 sensor in either degrees centigrade or Celsius or degrees Fahrenheit, depending on how a push button is pressed. Okay. So let's just get on that. Right. I've actually done this in two separate programs, mainly because when I did the first lot, I realised that there was a little bit of an issue with it. So I've improved it slightly in the second version, but that's a little bit more advanced. Setup is basically the same as Paul had for his DHT. The addition obviously is the push button. My DHT sensor, my original one, which was this one here, for some reason wasn't working properly, so I had to switch to another one, and this one actually only has the 3 pins down the bottom. It's basically the same DHT11 sensor at the top, but the 4 pins, only 3 of the pins are normally connected. One of them is just a spare, so only the actual 3 pins that you connect to are taken down off of this little board. This one also has a little LED just to show it's running, but it's basically the same setup. So you've got 3.3 volt in one side, you've got the ground connection out the other side, and then you've got the data pin, which is in the centre on mine, which I've taken back to pin 16. Okay, the push button, again, ground here, which obviously taken back to this ground pin here, and then the positive side I've taken back to this pin here, which is GPIO pin 18. Okay, so let's go through the code. Start obviously by importing the machine, import pin. We'll import U-time as time. Not quite sure why Paul suddenly switched to U-time, but I'm sure it will be revealed in the next lesson. And then from DHT, import the DHT11. Okay, as I said, data pin is on pin 16, the button pin is on pin 18. Then we set up the pin for the DHT, which, as Paul said, is actually a pin out, even though you'd expect it to be a pin in. So that's on the data pin, pin out, and we're using the pull down resistor. And then the sensor is the DHT11 on my pin. The button, that will be an input pin. So we've got pin, the button pin, pin in, and we're using the pull up resistor. Then I've started, as I've done with previous lessons, for detecting the button state. We check what the button state is to start with to give it a value. And then I've also given another variable here, which is units, which I've said is true. And then into the actual main workings. So we start off by printing sensor readings before the actual loop starts. Then we're going to have a new variable, previous button state, which is going to be set initially to what the button state was before we started. And then we're going to check what the button state is now. Then we're going to read the sensors, read the sensor, measure it, and then set up the 2 variables for the temperature, sensor.temperature, and the humidity, sensor.humidity. Then we are going to say if the button state is greater than the previous button state, so if the button has been pressed and then released, then we're going to say units is not units. So basically that's switching units between what it was and what it will be. As in, if it was, what we're basically saying is that true will give us a degree centigrade reading. If it's false, so when we say units is not units, if it was true, then it will then be false. If it was false, then it will become true. If it's false, then we're going to have a Fahrenheit output. So if the units is true, print, and we use the /r as Paul demonstrated in his lesson, just to make sure it overwrites on the same line all the time, rather than having a big scrolling lot of text. We're going to print temperature, then the temperature reading from the DHT11, then degrees C, and then we're going to print humidity, and the humidity reading from the sensor, and percent. And then we end the /r so that next time it starts reading at the same point again. Or writing, sorry. If it's not true, then we do the Fahrenheit, because if units is false, then it won't do this one. It will instead go to this bit and say, and at this point we'd say, right, because units is false, we want to convert the temperature from temp C to temp F, and we do that by multiplying the temperature C by 1.8 and adding on 32. And then I'm putting that as an integer just so that you haven't got lots of decimal places after the main number. And then we print out basically the same thing but with temperature F, so the degrees in Fahrenheit, and we have an F after it instead of a C. Then we sleep for a second just to give the sensor time to relax before it starts sensing again. Okay, that's the hopefully that most of that made sense. Give it a go and see if it works. Okay, so there you go. Sensor readings, temperature 28C, 27C, somewhere around there. 46% humidity. It's actually quite warm in the UK here at the moment. And if we press the button, then we change to 82F, and obviously the humidity stays the same. Press the button again, press the button and nothing happens, and we release the button and it changes to 28C. Now I said earlier that I found a bit of a problem with this program when I first started writing it, and the problem is if you press the button too quickly, then it doesn't recognise it, because obviously it's sleeping for a second before it goes back into the loop, and that second, if you do it at the wrong point, then it's not going to detect that the button's actually been pressed. So you have to actually hold your finger on the button pretty much for a second in order for it to detect that the actual button state has changed. Now, there is a way around this, and that's what I've done on the second program. So if we stop this one, we go into the second program. A lot of this is very similar. Obviously it's still the same setup as far as the actual circuit layout. So again, we're importing the pin, importing U-time, importing DHT11. On this one we're also going to import a thread. Basically thread, if you're aware, the Raspberry Pi Pico basically has two cores, so it can run effectively two programs at the same time, and you use thread in order to do the second program. So this is the same as the previous program. Data pins are the same, setting up the pins exactly the same as the other program. On this one, however, the units, I've actually called it unit C on this program just to make it clearer. We're going to make that a global variable, simply because it's going to be used in both of the threads. So we call it a global unit C, and we start off with it being true. Then what we do is we set up the first thread, and basically what the first thread is going to do is just check the state of the button. So define the unit change thread. So what we're doing is we're checking the state of the button. We're importing the global unit C variable, and then we're saying while true, do the same as we did on the other one with setting up the previous button state and checking it against the new button state. And this time, if the button has been pressed and then released, it's going to change unit C so that it's not unit C. So again, like the previous one, if unit C is true, then it's going to give us, when we come into the main loop, it's going to give us a degree centigrade. If unit C is false, then it will give us degrees Fahrenheit. Now, as this bit is only literally just checking the button, we can have a very short sleep on there of just 0.01 of a second, just to slow it down a little bit as it goes through. Then once we've done the the unit change thread, then we come into basically getting everything else started. So thread.start, the new thread. So we're starting the unit change thread, and we're starting a main thread. And the main thread is this one. So this is the program which is actually doing most of the work. So obviously the button change is going to be checked here, but the main work of checking the sensor and printing everything out is done in this one. So we start by measuring the sensor as we did in the previous one, setting up the temperature C and the humidity, and then we say if unit C is true, so as we said before, if unit C starts off with true, if unit C is true, then we print out the temperature in degrees Celsius or centigrade. Again, basically everything else is the same as the previous program. Else, if unit C isn't true, then we convert the temperature C into temperature F, and we print it all out in Fahrenheit, exactly the same as the last one, and then we sleep for 1 second. Obviously this time we're not waiting for that second in order to check the button. The button is being checked every 0.01 of a second, but the sensor reading itself will wait for a second. So now if we run this one, again you see it's exactly the same as before, but this time, even if I press the button quickly, it will change between C and F. It may take a second for it to change once you've pressed it, but you don't have to hold your button, sorry, you don't have to hold your finger on the button for a second in order for it to recognise the button press. C, 82F. There we are. Thanks for watching. Hope most of that made sense. Hopefully you can read most of the code there. Obviously these lines have gone off the end, but you should be able to get most of that. There we go. Okay, thanks for watching, and see you again next week.